Hello, let's solve pips. We've got 1 by Ian and 2 by Rodolfo today. We'll start with the easy puzzle. Let's place some dominoes. All right, what do we... Oh, this is interesting. Look at this. We've got... Well, we've got either 6 5s to make a 30, or 4 5s, a 6, and a 4. That's interesting. Oh, but we need a 6 and a greater than 5, so it's all 5s in there. So I think what that means is the 6 points to the 5. A less than 2, which is only a 1, points into the, with a 5. Yeah, this will just continue here. We need a double 5. We need a 5 4 that's greater than 3, then a 5 3. There we go. Okay, so once you sort of see what's going on, that one you just slot them all in. Let's try the medium. Oh, another very compact puzzle today. Okay, so we need two pairs that make 10. And those will both be 6 4s because we only have 1 5. So we only have 2 4s. So I think the 4 needs to connect these. And then our 6s point outwards. So, and they both point into doubles. They point into different doubles, which means the one down here goes across. I don't know if it's this one specifically, but I don't know. It might as well be. Let's just try it and see. We need a double 2 probably over here. Yeah, I think this... No, this doesn't work, actually. Right. Let's try it the other way around. Sorry. Because it's such a small thing, I just kind of going for it and just seeing what happens. But I know that's not the most scientific way to solve this. Yeah, this is fine. Oops. Okay, there we go. That could have been better. What can you do? All right, we'll move on to hard. Oh, right. This is interesting looking. Is that a lambda? Okay, so we've got less than 2 connecting to something that doesn't break 4. So we've got a 0 or a 1, but we've actually got several ways to achieve that. We've got less than 3 connecting to something that can form 9. So less than 3 connecting to something that is 3 or higher. And we don't have an enormous number of those. I mean, yeah, we've got a few still, though. We've got just 2. 1 4 and 3 3. Yeah, that's a little bit restricted. Then we've got so we've got a 5 or 6 connecting to something that has a double, which could be this, or could be, I mean, it could be any number of things. It could be this. It could be this. Right, okay. How are we doing this? We've got a single 0. Where could that go? I bet it's going to go in the inequivalence region, but that's just a hunch. Could it go here? Because it could, in theory, go there. This would be very restrictive because then we'd only have this double 3 here. Then the problem is once you get this far, well, now we have lots of 6s, and all they have to do is go into the inequivalence region, which is not difficult. I mean, there aren't very many places this could go, actually. It could go over here as well. No, it couldn't. It could not go over there. All right, well, and there's only one of them. So it either goes here, or it goes somewhere that either interacts with this void stuff or goes into the inequivalence region in some way. But, I mean, there's several ways to do that. Even here would be theoretically, no, that wouldn't be possible because that would mess up those areas. But, this would be possible. How do we do this? We have lots of 6s. We have 1, 2, 3. We have 4, which isn't a huge, huge, huge number. But only one of them can go in the inequivalence region. One of them could go in the void. But then we couldn't have any that go here. We could have 1 here. I mean, it's still not hard. We've got 2 9s. Plenty could go in there. Sorry, there will be a very clever way to approach this that someone will point out in the comments that I am currently not finding. That's my prediction. Well, I know that I'm not finding it. My prediction is someone else already will have. The less than 2 is 0 or 1. My suspicion is it's going to be 1 because I bet we're going to want the 0 for the inequivalence region. How many total distinct numbers do we have? 0, 1, 2, 3, 4, 5, and 6. We have all of them. So I was thinking maybe the inequivalence region would be somewhat constrained. Not very. I do think if we put the 0 here, it makes the inequivalence tougher, probably. Actually, you know what? It does. It does. Because then we've used the 3's. We have no more 3's. So now we only have 2, 4, 5, and 6. We only have exactly the correct number of individual digits for that. No, we don't. We don't, sorry. We have 1, 2, 4, 5, 6. We still have 5 of them. Ugh, even that's not as difficult as I was thinking it was. What is the deal here? What is going on? I mean, I still think this is probably wrong. This 6 would then need to be 1, 5, or 2, 4. It couldn't be double 3. Actually, it could never be double 3. Because the only way for it to be double 3 would be this, and then that messes up this area down there. Not a huge win. At least it's something I know. I don't really know if I could do anything useful with that. So this less than 3, it can't be this 0, 1, of course. Can't be this 1, 2. Can't be this 2, 2 either. So it's... Oh, it can't be any 2. So it is a 1 or a 0. Could it be the 0? No, it couldn't be the 0. It's got to be a 1, right? Is there anything else that it could be that could go into the 9? I don't think so. No. No. It would have to be a 0 or 2, and none of those works. Okay, so it is a 1. So it's 1, 4, or 1, 6. So this is 5 or 3. 5 takes away our only 5. So if this were 1, 4, this would have to be 5, 4. Then this would have to be 2 something, which, again, that's not very difficult. Yeah, what is the thing I'm missing here? We still have almost all of our digits left for the inequivalence region up there. I am obviously missing something important. I mean, that is clear. What isn't clear to me is what that thing is. Less than 2 over here could still be 1 or 2. I mean, there's some places where it's difficult to put small things, like in 9s, but... And I guess we're limited on where we can put 6s because, it can't go in that 6, it can't go in that 5, can't go in the less than 2 or the 4. And we do have a bunch of them left at this point, actually. So, greater than 4, I mean, could we get rid of 2 of them right here? Because, yeah, we could, actually, because we could put the 0 here. And then, yeah, we could easily get rid of 2 more, because we could put one of them in that 9. Actually, we couldn't. No, we could, because we have 2 3's. We could do this. And actually, we couldn't do that in this world. Actually, in any world. No. Yeah, if we could do this. Yeah, it's not that hard. And then this could be, I don't know, something like that. It's not difficult. I mean, I'm wondering if this is going to be a case where there are actually many ways to do this. No, that doesn't work. This would need to be this way then. Yeah, this is tough. Yeah, this is impossible. I mean, it's not that I think it's going to be easy to do and that there are going to be lots and lots of possibilities. I'm just not sure how to narrow it down, and I think I can imagine there being more than one, but I bet there won't be. I bet there will be one possibility, and I'm just not saying how to get there. But I mean, just going through that exercise, it's not trivial. And to be fair, I was putting something in that I thought was going to be wrong. How on earth do we do this? If this greater than 4 is a 5, I mean, there's only one 5. That takes away a 5 immediately. Then we need another 4. It's not very difficult. It could be 4, 1 or 4, 4. It doesn't seem hard. If that's a 5 there, then this 6 is not 5, 1. We already know it's not 3, 3. So it's 6, 0 or 4, 2. Could it be 6, 0? I mean, I think so. Yeah, I don't see any particular reason why that would be difficult. Actually, that couldn't be that. It could be, no, actually couldn't be that either. Actually, that's not possible in this situation, I don't think. This would only be possible if we could use that 5. So I don't think that can be 6, 0. So it wouldn't be 6, 0, and it wouldn't be 5, 1, wouldn't be 3, 3, so it's 4, 2. I mean, again, that's such a small restriction. I don't see why that would matter, really. What if we use our only, I don't know. What if this is 6, 0? Can we just rule that out entirely? The 0 couldn't go this way, so it would need to go this way, and then this would need to be a 6, which would have to be this one. It would have to be this 1, 5, and that doesn't work. Yeah, so this isn't 6, 0 ever. So it's not 6, 0, it's not 3, 3. It's 2, 4, 1, 5. So can we rule out the 5 ever? I think that one's much harder to rule out because we could put this here or we could put it here. No, we couldn't put it here actually because then we'd need another 5 and we don't have one. So it would actually have to be this. And I think putting 4s in here is going to be tough because we have a bunch of 4s, but I don't know. Let's just play this out. So then we have 1 coming off of that, which could be not this 1, 4, because then we would need another 5, but it could be this 1. No, it couldn't. I tried this already. Okay, so I guess the 6 is 4, 2. Is that right? I think that's right. I think the 6 has to be 4, 2. The problem is we've got a whole boatload of 4s and 2s. We've got 5 4s and 3 2s. So 2s are the slightly tougher one. So I guess this one couldn't be a 2. The bottom part couldn't be a 2 because we don't have any way to put it into the 9. So the top one would have to be a 2. Okay, so that's something. The top of this 6 is a 2, I guess. And the bottom of this 6 is a 4. Couldn't be this one. It could be. No, it couldn't be this one either, actually. It couldn't be the 4, 6. So it's 4, 4, 4 or 4, 5. No, it couldn't be 4, 4 because then this would have to be 5, 4, which it can't be. So does that mean this has to be 4, 5? I hope I haven't talked myself into something wrong, but I think this might be correct. And then this would have to be 4, 1. I think this might be the only way to do this. And then the top of the 6 is 2, 1 or 2, 2. Just looking at how much time this has been. It's been more than it should be. But I think that's right, probably. Is it? I hope so. So then we've got 2, 1 or 2, 2 pointing out of there. I mean, it's not a huge gain, but it's definitely something that I believe is probably correct, unless I've made a logical error, which is entirely possible. So we've used our sole 5, which means this greater than 4 up here is a 6. But it's not very restricted because we've got lots of, any of our 6s have additional examples that could follow from them. And we have ones that could definitely go into a 5, so that's not a problem. 6, 4. We've got, we could put a 4, 4 into the 5. That's fine. In fact, that's the only way that one would work. And then 6, 6. I mean, similarly, We could put a 6, 4 into the 5, or even this 6, 1 into the 5. Those are all fine. Those are all fine. Were there any of these that I was using down in this area? Maybe that 5 with the 9 was used for something. So if we go back to our 0 in the less than 2, then this 4 would need to be this double 3. Then this would need to be a 6. That doesn't seem tough. Maybe it's tough in combination with the inequivalence region over here, is it? I don't think so, because this could be 6, 1, and then this one could be 2, 2, for instance. Or, I mean, whatever. I mean, this could be a 6, 6. Does using this 0 cause any problems elsewhere if we do that? I don't think so. If anything, it's tougher to put a 1 in here, actually, with respect to that 5 region. If we put this, well, I guess if we put the 1, 0 the other way around, this one would then have to be 4 going into something that makes 9. It couldn't be a 4 going into the 9. So it would have to be this 6, and then this would need to be a 3. This still doesn't seem like it's causing a big problem to me. This 5 would now need to be 1, 4. But it could be, because this could be that. You know, I mean, I'm just putting things in randomly almost, but just trying to think about what they mean. Oh, this works. I don't know if that was the only way to do this or not. Sorry. So I said I was sort of putting things in randomly, but trying to think about how they work. What I mean when I say that is I was sort of trying to think about what are the more. I mean, this is generally what I do when I'm getting a little stuck on pips. Is I try and think about what is restricted, and therefore, when you put things in, what likely effect is it going to have elsewhere? And then when I'm sort of trying to narrow things down, I'm just thinking, okay, well, we know that this 5, for instance, needs to be 1, 4 in this sort of hypothetical situation I'm in. So what can we do that will lead to that just based on what we have left is not going to ruin our inequivalence region too much? And it's not logical deductions, because I'm thinking about likelihoods more than actual things that have been ruled in or out determinedly. But sometimes I'm just not quite sure how else to proceed, and this was one of those times. So let me know if you have a beautiful and elegant solution to this puzzle. I'm sure some of you do, because I would like to I would like to rely on that strategy less, to be honest with you. But anyway, there we go. Those were the pips. Back tomorrow. Bye for now.